Hi guys, my name is Pradeep Udekar. I'm developer at Equal Experts, and we will be talking about why some of the installations of MongoDB can result into slower performance and how can we improve them using the indexes. So let's take a general scenario. What happens when some developer reads about MongoDB, as it is a NoSQL database and that's the running trend these days. So people just hear about those cool DB and they tell it to their teammates, and the team says, why should we use it? So we can say it is too fast, it is a document store, so it can accept any kind of data, there is no fixed schema associated with it, it is a schemaless database. And then it is almost like RDBMS. You can use collections instead of tables. You can even use references to simulate joins, and it is very easy to scale with sharding. Another advantage is that MongoDB provides replica sets which can back up your data while you're running your application. It all seems to work just fine, like clockwork. You might think that this is God's gift to mankind, right? But then there's a time to go to production, and then suddenly we can see that all of your queries are performing slow. You're not getting the results in expected time. You are not seeing updated results, although the data that you just updated, it is present in the database, it is not written by the query. So what is happening over here? Are we missing something? There has to be some reason to this. And then we say it's all MongoDB's fault, right? If you were using RDBMS, you would not encounter such problems, and that's when the team says MongoDB sucks. But before jumping to this conclusion, I think we should first understand what is MongoDB. MongoDB is a document database. It means MongoDB stores the information in the form of a document. You can think of a document as a key value collection, where your keys will be string and the value can be of type strings, the numbers, floats, integer, boolean. It can also contain arrays which can contain the other types. It can also contain nested key value pairs as well, as you can see here. This is almost similar to JSON with subtle differences. It is very simple to use. It is very easy to install. It's very to get started with, and even the syntax to work with MongoDB is very easy. You can almost read it as English language, and that's why people prefer to use MongoDB. But remember, MongoDB is not solution to all the database problems. It can be a very bad tool for certain jobs where you want to store very complex relational database structures. Although we say that, MongoDB is certainly the best choice in some of the scenarios. Now, what will be those scenarios? How will I know whether MongoDB is a good fit for my model or not? So to decide this, you need to ask following questions. Does your data fit a document model? What do you mean by a document model? It means you need to understand whether the domain objects that you're working with, do they have any complex relationship with each other, or those data can be isolated into discrete documents which doesn't rely mostly on each other, and that's what we would call as a document database, right? Because we will have all the data into a document contained in that document itself. It doesn't need to refer to any other collections or any other tables for integrity. The second question we would ask is, do you need transactions? As MongoDB doesn't support transactions, you will have to be very careful when you will deal with the transactions in your code. In most of the RDBMS systems, the database takes care of transactions, but here you will have to handle that yourself if you are using MongoDB. Let's say if you are working with scenarios where there are multiple workflows and all your workflows depend on each other and they are transactional, in that case MongoDB might not be a good choice for you. The next question you would ask yourself is, do you need real-time aggregation? Are you doing real-time reporting? Let's say you are dealing with millions and billions of documents, and when people read about MongoDB, they say it has good support for MapReduce and aggregation framework. Although there is support for that, it is not a tool for real-time reporting. It can slow down your performance. Although there are certain scenarios in which you can optimize the aggregation framework, but I would prefer not to use that on your live installations. You can use it on a backup replica set only for reporting. Are your queries well defined? Do you have to know what kind of queries that user are going to fire against your MongoDB database? Unless you know that, you won't be able to specify correct indices to optimize your queries. And that's why it is a very important question to know whether you have control over the queries that you're going to get on the MongoDB side. You cannot fire any arbitrary searches on the MongoDB. If you do that, your database will slow down if there are no indexes for those arbitrary fields. Once you have all the answers to your questions, then you can know whether you wanna start working with MongoDB. And the first step to start with MongoDB is to create a schema for your database. What? I think most of you guys know that MongoDB is a schema-less document. That's why it's a NoSQL database, right? It breaks the traditional rules of RDBMS where there is no fixed schema associated to it. It is partially correct. That means although it can accept any number of fields on the runtime, you don't have to define all the keys in your document beforehand. I would not say it is schema-less. I think it has a flexible schema. It has a certain schema which is of type a BSON document, and that document requires you to follow certain guidelines, certain rules. Think about the denormalization. In traditional systems, you will try to optimize your database in such a way that you don't have to duplicate the data everywhere. What you would do is, if there is a category and a product, you might want to have a product table and a category table, where product table is referring to the categories, so that if you change category name in the category table, it will be reflected across all the references in the product table. But in MongoDB, you can think about your data design in such a way that even if your data changes for one document, that's not really going to affect in another document. And also the things that you can afford to duplicate, which are not going to frequently change, you should put that in one document instead of creating another collection and referring to that. For example, let's say if I am creating a database of let's say listings in my business listings, and I want to create a relationship between all the businesses and the city and districts as well as states. So the information about city, district and states is not going to frequently change. That's why I think I can afford to duplicate that information in each of the document for my business listing, instead of creating a separate table for each of the cities, the district and the state, and then refer to that. That's gonna add a lot of overhead when I'm doing joins in my queries, and that's why I would avoid that kind of denormalization. Keep in mind that although MongoDB is schema-less, there is the limit for how much data you can put into the document. You can only put 16 megabytes of document with the current version of MongoDB. And another thing is, you cannot have 100 nested documents inside one document. Now you understand what is a nested document means. That means you are going to have one BSON document object as a value and into another BSON document, and there is a limit to it, because if you put more than that, you are going to hit a lot of performance problems. So I would strongly suggest to keep your document structure as flat as possible. And we say that although there are references in MongoDB, you should be very cautious while using them. Try to think of references only for exceptional cases. Now what would be an ideal schema in that case? So let's take a look at this schema, which tells you about the information about a movie. Here the information like the title, release year, average rating, favorite, and the cast of the movie, also the reviews, they are completely isolated. They are part of this movie. They don't have to do anything with another movie or any other type of media. And that's why I can afford to maintain the state of this my movie object into one document. And it is not completely flat either. It has an array of actors. I can have array of reviews, which is another complex document, and I can do all sort of stuff with this kind of document. So folks, I think you have a pretty good understanding of MongoDB now, and let's see how we can use indexes to improve the performance of our MongoDB setup.